Alright, so here we are with our first normal form, and we would like to move now to second normal form. Okay, there's really only one condition for second normal form, and that is that there are no partial dependencies. Now, to understand what this means, we have to understand the concept of functional dependency. And all that really means is that it takes one field to determine another field. Alright? In other words, one attribute is dependent upon another attribute in order to figure out what the value should be. If we look at order number here as part of our primary key, well, let me back up for a second. A partial dependency really just means that an attribute is dependent upon part of the primary key, but not all of it. Okay? And so it has every attribute in the table needs to be dependent upon the key, the whole key, and nothing but the key, right? Ultimately is a good way to say it, except we actually do it in multiple steps. So let's take a look at our first non-key attribute here, order date. Is it dependent functionally on order number? Well, yeah, right? Because the order 100 was taken on 1/1 of 99. So we can determine the order date via the order number. So order date, we can say, is functionally dependent upon order number. Now, is it also dependent upon item number? Not really, right? Because the order date would have been 1/1/99 regardless of what item was ordered on it. So order date is not functionally dependent upon item number. Therefore, we have a partial dependency. The same thing is true for customer number, name, and address. All of these are functionally dependent upon order number because the order determines which customer placed it. Okay, that makes sense. But these attributes are not dependent upon item number. These would be the same regardless of what item was ordered. In fact, they are. You can see it. As the item number changes, the customer number, name, and address, and order date do not change. Right? That's a good indication that you have a partial dependency there anytime you have duplicated attributes like that within the same set. But now if we look at items ordered, we say, well, this information, the quantity, the description, the pounds, is dependent upon the item number. That is true. And the order number. Not really. It's not really dependent upon the order number. The items ordered is really dependent upon only the item number. Okay? In other words, you ask yourself, could you determine this information with only item number? And the answer is yes, at least partially. The description and the pounds at least. The quantity and the amount are actually fully dependent upon the primary key. But again, we'll get to that in a minute. Second normal form is where you're going to spend the bulk of your effort here because there are numerous partial dependencies and you kind of have to go through this in an iterative fashion to understand what's going on. And so we've actually got several different tables that the way you fix it is you're going to have to break out into separate tables, right? And it kind of is intuitive here because you can see the need for a customer table, right? Because we're duplicating all this information when really what we need is our own customer table. The other one that's not terribly intuitive, but I think it will become intuitive the more that you deal with it, is the fact that we have some information in an order that is dependent upon the order itself, such as the order date and the customer number, right? In other words, those are dependent upon the order. It really doesn't matter what they order, whereas some other information is dependent upon the specific items that they order, like the quantities, for example, and the price. And so those are really fundamentally different, and therefore they require a separate table as well. So what I have here now, this is the second normal form of this data. Notice down here that I have created a customer table, right? And keep in mind that we're maintaining second normal form, which means that each of the normal forms also have to be in compliance with the prior forms. So does customer contain any repeating groups? No. Does it have a primary key identified? Yes. Does it have any partial dependencies? No. Because customer name and address depend on customer number completely, all right, and nothing else. Of course, if you have a single key as a primary key, then almost always you're never going to have any partial dependencies because, well, how can something be partially dependent, right, on a single attribute? It's usually when you have a compound primary key is when you're going to have a partial dependency. All right, so that's actually easy. Now, also notice that we have in the order table, I have stripped out most of the fields, and only all I have left in the order table is the date and the customer number, right? Because those are really the only two attributes that are dependent upon the order. And I've also removed item number as a key field, part of the compound key for order, because, well, I don't need it anymore, right? Because order date and customer number are not dependent upon item anyway. So order number alone can serve as the primary key for this table, and then order date and customer number are fully functionally dependent upon order number. Now here's the piece that's not maybe completely intuitive. I've created an order detail table. These are the line items that are associated with an order. And so here for the primary key, I have created order number and line number. So order number alone would be insufficient because notice that it duplicates. So I have just created, out of thin air, a brand new attribute called line number, right? Which is just sequential line numbers on the order. They order line 1, 2, 3, 4, 5, and so on and so forth. So the combination of these two establish uniqueness, so that makes a good primary key. Consequently, line number also makes a good part of the primary key because it's not dependent upon anything. It's just literally a sequential number that we made up, right? But it makes intuitive sense. All right, so a couple of other things to note here is that order number is not only part of the primary key, compound primary key here in order detail. It's also a foreign key, right? Because ultimately I have to relate order and order detail. So I have order number here, part of the primary key, and it's also a foreign key back to order number, and that's perfectly fine. Now, I still have item number in the order detail table, but it's not part of the key because I really don't need it to be. And another reason why we would use line here is because it's part of the primary key. It actually grants me the flexibility to refer to the exact same item on the same order without violating any of the normalization rules. And there are reasons why you would want to do that. It makes the system more flexible. And also the other thing that I've done here is to separate out all of the different fields because it's called atomicity. We want to have each separate data element in its own attribute. We don't want to put them in the same one. Where you see this a lot is like in a customer address right here. Now this doesn't contain city, state, zip, anything like that. But if it did, you would not want those in the same attributes. You want to create separate attributes, address, city, and state, and zip, right? And actually, if you want to get real technical, you might want to even separate the number and the street into separate ones. Depends on how technical it needs to be. Okay? But now let me flip over here to my Visio ER diagrams and show you this is corresponding to what we have just created. Okay? So what we have done is strip all the customer data except for the customer number out of order. And we've created a customer table over here, and notice that it relates in a one-to-many, right? With our customer number primary key over here and my additional attributes of name and address. And so what this is saying, if we look at the cardinality here, a customer can have 0 or many orders. An order must belong to one and only one customer. Okay, so that makes intuitive sense. And we still have to have a customer number as our foreign key in order to establish the relationship. By the way, one good rule of thumb to remember is that the foreign key always goes on the many side of the relationship. So look at the cardinality, see the crow's foot here? That indicates a many. That's where the foreign key goes. Okay, the primary key is going to be on the one side of the relationship. Also over here, here's our order detail table. Notice I've created independent attributes for the different bits and pieces that we have in that original layout that you're given. Order number and line number are both primary keys. Order number is also a foreign key. That's perfectly fine. Doesn't create a problem. And then I have all these non-key attributes over here. Now, if we look at the cardinality, an order can have 0, probably not, probably at least 1, but 0, okay, when you're creating it, and many detail lines. In other words, we hope that a customer orders many different things from us on the same order. But a given order detail record will only ever belong to one and only one order. In fact, it's what we call a weak entity. It won't exist unless there's a corresponding order. You would never create an order detail that referred to an order number that didn't also exist in the order table. Okay, that's why it's called a weak entity. It can't exist on its own without a related record in the order table.